Now we are going to do an interesting question that how to implement a priority queue with the normal queue. So the quite simple answer is that we can implement priority queue with two normal queues. Now let's actually have a look at which operations are available on a normal queue so that we can implement a priority queue. So what is a normal queue? A queue is actually a data structure like plates which are actually placed one after another, and then we have two pointers here. One is actually called the front and another is rear, and the front is actually at the start, which is actually pointing to the element that was actually placed here in the queue at the previous point of time, that is the earliest point of time, and the rear is actually the one which is actually inserted into the queue just now. And what we can do is that we can pick at this particular point, that is we can just pick at that particular data that it was inserted at the earliest point of time, and also we can just remove it by using the dequeue function, which is removing the first one. So how can we implement a priority queue? We will require two particular elements and two particular queues for this priority queue implementation. So what we will do is that we will a priority queue is a queue which actually maintains an order of the elements so that we can get the minimum and the maximum in big of one time. So one answer is actually given as stack overflow, is that you can implement a priority queue in such a way that if you want to insert all these elements into a queue, into a priority queue, then you can do as follows. That's what firstly the two will come. Your queue is empty, so you will just insert it into one queue. Then your four will come. Then you will do what is that from the first queue you will try to find its place in the ascending order. So you will first compare it with the start element. Start element is 2, but now 4 is actually not lesser than start element, so we will not insert 4 into the second queue, but instead we will my implementation says that we must actually dequeue from this particular queue into the second queue, and then when the queue is empty, either queue is empty or the element actually comes greater than 4, then we will stop, and then we will insert or say append this 4 into the second queue, and then we will append the rest of the elements from this particular queue till it is empty, right? So it becomes 2 4, and then but when 1 comes, we can actually compare it with the start, that is a front element, that is actually equal to 2, and we can see that it is actually greater than 1, so 1 needs to be inserted at the front. So in the next queue, in the next queue, which is actually another one, we can do is that we can insert 1 there, and then we can just we know that the start element is already smaller, greater than the 1, so all the elements need to be inserted after it. Now the 5 comes. We don't know, we can only look at the front element. So in the next queue we will have the element like 1 2 4. Now as the 5 comes, we know that the first element, that is actually equal to 1, is smaller than 5, so 5 must not come in the front side but might be somewhere back at the back side, but we don't know what is the position of that. So we will start from this 1, and we will keep dequeuing the elements till we reach a position where the front element is actually greater than 5. So in this process we will just dequeue all the elements, and then we will be left with 5 as the last element, because we will be left with null because 5 is just greater than all of them. Then we will just append 5 to the second queue, whichever is actually available. Now when the 3 comes, then we will start from the 1, and we will start dequeuing the elements from 1. Then we will dequeue 2, and then when 4 comes, then we will get to know that 3 is actually smaller than 4, so it needs to come before than 4, and then we will just simply append this 3 after 2, and then we will dequeue the rest of the elements like the 4 and 5, and we will just append it to the next to the say next pointer of the previous queue. In this way I can implement a priority queue, and I can get the minimum at big of time. That is actually what is your priority means. If you are maintaining an ascending order, then you will be actually maintaining the get min function in big of time, and if you are maintaining a max priority queue, then you will be just sorting these elements in the descending order, and in this way you will get the you will get the maximum element in big of one time. So let's try implementing this particular stuff. I hadn't tried this, so let's actually try this for the first time in the C++ in C++. So let's actually firstly let's actually try implementing a simple queue. So hash include istring using namespace std ultimate and return 0. Now I will try implementing a queue. So it is kind of a node structure. So I will make a node, and then in this node I will have anti-data, and then what I have a pointer. So node star next, right, is equal to null. I can initialize this as null. Also data will be 0, or say not inserted, -1, and then I can implement a queue. So what I can do is that I can create a class queue, something like this, and I can do this, make all the methods to be public. Then I can have some pointers called node star front and node star rear, right? And then in the public I will have the enqueue method with some anti-data, something like this. It will be public void, sorry, not public, that's actually Java syntax, void anti-data. And then what I have is that I will just create a new node star n is equal to new node. And I think I can also create a constructor in a struct also. So node anti-data. So this the data, or whatever I can say. I think that there is a this pointer in the struct also. Let's try compiling. There's a lot of time doing things in C++. I always prefer JavaScript. Okay, so node size is node is called new node, or we can do something like this. Yes, there is a constructor, or we can do with another syntax is that we can use the reference operator, data is equal to data, something like this. But I will prefer this one, right? And I can also create a normal constructor which will do nothing. So this is the enqueue function. What I will do is that okay, so this is the node created, and now I need to actually okay, so what actually happens in a queue is that when a new node is actually created, it is appended after the head of the front. If front is now what is actually a front? Front is a pointer to a pointer, because it will actually store a pointer which is actually it is actually storing a pointer, so it must be a pointer to a pointer. So if I think that if the pointer to pointer is actually a null value, then what I can do is that front will be equal to n. Else if something is there on the front pointer, means front is actually pointing to something, then what I can do is that I can actually get the okay, so sorry, front is equal to n and the rear is equal to n, right? So rear will also point to n. Well, one second, I don't need to do this way, I can do simple way also. Why I need to do a double pointer? I can do a single pointer itself, so real will be also 1 to the first element. Otherwise, what we can do, if front is equal to null and the rear null, right? This way means both are actually pointing to null, means that our queue is empty. So what I can do is that I can make the rear's next point to n, and the rear will become n. Rear will come to the end in this way. And then what will be our dequeue function look like? Dequeue function will actually look like this way, that it will just remove from the front. So what is actually front? So front will be in such a way that the front nodes to be delayed node star del is equal to say front, and then front will become front's next part, and then delete del, something like this. So this is what we can do with the dequeue function. And then what else we have? So we can have a traverse operation here. What traverse? Something like this. So I will have node star t is equal to say I can traverse from front to say rear, right? Um, yeah, I can traverse from front to rear means from the previous point to last point. So while front is not equal to null, then what I can do is that see out front data, and then front will become front's next part, something like this. And I can also leave a space. So front will become front's next part, and it will actually keep on going. So this is my traverse operation. Now I have another operation which is called void peak, which will actually get me the peak value if front is not equal to null. See how value will be equal to front data. So this is just the implementation of a normal queue. Now we will convert it into a priority queue in the next session by just using this particular queue in our next session. Thank you so much.